Hello learners, welcome students. I am Dr. Prasad Narayan Patil, Assistant Professor in Physics from Ganpat Parsekar College of Education, Harmal, Goa. Today I am discussing in this module, that is understanding matter from solid to plasma in everyday physics with demonstration. Outline of my talk will be three states of matter, that is solid state, elasticity, liquid state, Archimedes principle, gaseous state, Bernoulli's principle. At the end of the module, learner will be able to know what is a matter, example of matter, what is matter made up of, different states of matter, that is solid state, liquid state and gaseous state. Properties of matter, that is solid, liquid, gas and plasma, Archimedes principle and finally Bernoulli's principle. So let us see what is a matter. Air all around us is made up of matter. Water we drink is also made up of matter. Everything is made up of matter. So universe, whatever the matter consisting of, that is air, water, is everything is made up of matter. So we can say that matter is anything that has mass and occupies space. Matter has mass, matter has some weight. Second one, matter occupies space, matter needs space. Example of a matter. Take a example of matter to understand a water. We are having an empty beaker placed into the weighing machine. It is showing the lowering of the scale. So if we are just pouring water into the beaker, then what we are going to get, there is a increase in the weight. So we can say that water has mass and weight. What is the matter made up of? Matter is made up of tiny microscopic particles called molecules.
So इस लाइन पर माशे रिपीट करके बेल वाजली आवाज येतो इट्स लाईक
परत म्हणू. What is the matter made up of? Matter is made up of tiny microscopic particles called molecules, and further molecules are made up of atoms. The density or the space between the particles in matter determine what type of matter it is: solid, a liquid or a gas. So there are three states of matter, that is a solid, liquid and gas. Different states of matter. Let us understand what is the solid state of matter. In a solid state of matter, particles are very tightly packed and cannot move, and this is why solid object cannot change their shape. So solid matter having a definite shape and size. In a liquid state of matter, that is in a liquid, particles are loosely packed and can move. This is why liquid object can change their shape. So liquid matter having a definite volume and lacks definite shapes. In a gaseous state of matter, in gaseous, particles are loosely packed and free to move. This is why gaseous objects do not have any shape and fixed volume. Gas matter neither having a definite shape and size. So let us understand the properties of matter in a solid state. So first one we'll see what is how we define a stress. It is the internal resistance of a material to external force without breaking or yielding. So if you see, we are having a material, when we are applying a compressive force, then what will going to happen that this internal resistance of a material to external force without breaking or yielding will going to take place. In a second case, the tension of the same material, if you are applying the tension for the same material, then the material will going to sustain up to the maximum stress, or it will going to show the maximum strength. And in a shear, the what will going to take place is the shearing of the edges of the material. ही परत रिपीट करू ही ही कॅन्सल करा परत. Properties of matter. Let us understand the properties of matter in a solid state. So we are going to know what is the stress. Stress, it is the internal resistance of a material to external force without breaking or yielding. So the resistance offered by the material when the force in a compressive force or a force in a tension force. So basically the stress is nothing but the maximum stress taken by the material. Either you are applying a force in the form of tension force, or in the form of a compressive force, or in the form of a shear force. The same solid state, the second that is the strain, it is defined as it is known as the deformation. So strain is a change in the dimension of a body due to the effect of the stress. So we can say that strain is nothing but the change in the dimension divided by the original dimension. So either you are applying a material compressive force, or a tension force, or a torsion force, you are going to get there is a change in the dimension of the material, whether you are applying a compressive force, tension force, or a torsion force. So that is the way we define as nothing but the strain. And finally, once we know the stress and the strain in the solid body, then we can define elasticity. That is, it is the property of material to regain its original shape after deformation when the external forces are removed. So elasticity is nothing but the stress divided by strain. So take an example of the spring which is attached as the rigid support. So at equilibrium position, it is not having any deformation. In a second position of the spring, you are going to see the deformation is carried out by the spring, that is the displacement x, and further you are applying more force onto the same spring, what you will going to get displacement is nothing but the 2x. So if you are removing this external force in the third case and the second case, the body will regain its original shape and size at a first case. Okay, so that is the meaning of the elasticity. Second example is the common rubber band what we are using it. Okay, so it can also going to have the stress is proportional to the strain. So within a elastic limit, what we are going to get a stress is directly proportional to the strain without going for a permanent deformation. Second property of matter, that is a liquid state. In a liquid state, that is the pressure in a liquid. So pressure in a liquid is owing to the weight of the liquid acting on the surface of any object in the liquid. So you see the one example where we have taken one container and object is deep. So we can say that pressure is nothing but the force acting per unit area, and this pressure of a liquid is directly proportional to this object is nothing but the gravitational field strength, that is a G. Second one, it is also directly proportional to the depth h from the surface of the liquid, and the finally density of the liquid, that is rho. So we can say that pressure of a liquid is directly proportional to h, rho and g. Now further we are going to see the pressure caused by the liquid, and the pressure in a liquid can be determined by using the equation below. So pressure caused by a liquid is given by this example that we are having one object exactly middle of the container, then we can say that pressure caused by the liquid is nothing but the P equals H rho G. But there is another atmosphere pressure will going to act on the surface of the liquid wherein the object is there middle of the container. Then we can say that pressure in a liquid will be determined by this equation P equals H rho G plus P atmospheric pressure. Let us understand in a liquid state only the difference between buoyancy and flotation. So I have considered the three different cases wherein one of the object is totally sinking inside the beaker, that is the first case. The second case, the object is just floating into the beaker on the surface, and the third one, the same object is just hovering in middle of the beaker. So let us understand what do you mean by buoyancy and flotation. So first case, if the weight of the object is greater than the buoyant force, the object will sink. So buoyant force is going to act from the bottom part of the container to the object, and because of this thing, the buoyant force will be having the weight of the object is greater than the buoyant force, the object will going to sink. In the second case, the weight of the object is less than the buoyant force, the object will going to float. So what I mean to say that the buoyant force in the second case is greater than the weight of the object, and that's why the object will going to float in the second case. In the third case, the weight of the object and the buoyant force are equal, therefore the object will going to hover in the water. Exactly middle of the container, the object will going to hover, because the equal and opposite force are acting from the both the side. That is the weight of the object from the top side, and the bottom from the container, it is acting the buoyant force, and both this weight of the object force and the buoyant force are equal and opposite. That's why the object will going to hover in a water. Let us understand Archimedes principle. Who was Archimedes? Archimedes was the most famous mathematician and inventor in ancient Greece. His contribution in geometry revolutionized the subject, and his methods anticipated the integral calculus. He was a practical man who invented a variety of machines. What is the Archimedes principle? Any object totally or partially immersed in a fluid or a liquid is buoyed up by a force equal to the weight of the fluid displayed by the object. So let us understand this Archimedes principle with one example. We are taking one container in a beaker, or a beaker having a water, and then we are not dipping any weight, that is 5 kg which is attached with the weight, we are not dipping it, and then the weight display on the meter will be 5 kg. When the same matter which is assigned with the meter will going to dip into the beaker, what will going to realize that the opposite 2 kilogram of the force will going to act into the opposite of the matter. So that 2 kg of the water will going to display into the second container. Exactly 2 kg of water will be get collected. And if you see, the first meter is showing us the 5 kg, exactly the weight of the matter. And in the second case, when the same matter, when it is dipped into the water, it is showing the 3 kg, and the remaining 2 kg is collected into the beaker. So totally it is showing the 5 kg. So this is the Archimedes principle one need to understand by this example. Now third property of matter is nothing but the gaseous state. So let us see, Bernoulli's principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in static pressure or the fluid potential energy. So I have considered the three different cases wherein here the one side, that is the right hand side, the flow of water is having a high pressure, which is showing us the low velocity. That's why there is a rise in the water into the first case will going to take place. And when the high pressure is going to propagate into the narrow pipe, then what we're going to get is nothing but the low pressure, and that is a high velocity. And you see the level of the water in the second case in comparison to the first case, it is a lowering because of the high velocity in the second pipe, that is a narrow pipe. When the same water is channelized into the broad pipe into the left hand side, what will going to happen, that the same low pressure is get converted into the high pressure, and it will going to show the low velocity, and there is a rise of liquid into the third container similar to the first case. So this is a Bernoulli's principle. And finally, properties of matter, that is plasma. So plasma is a state of matter consisting of free charged particles. So we can say that plasma is the fourth state of matter, and it is a separation of free charged particles. It is comprised over 99% of the visible universe. In the night sky, plasma glows in the form of stars, nebulas, and even the auroras that sometimes ripple above the north and south poles. So you can see the auroras basically in the north and south poles. So there are various examples of the plasma we can get into the nature, that is a lightning, second one is a fluorescent light, and third one is a solar wind. References for this module will be P.G. Hewitt, Conceptual Physics, 12th edition, Pearson. Second reference, David Halliday, R. Rusney, and J. Walker, Fundamental of Physics, Extended 5th edition, John Billy and Sons. Third reference, D.S. Mathur, Mechanics, S. Chand and Co. Thank you.